Hello and welcome to today's revision lesson where we're going to be discussing about preparation of soluble salts. I am your usual host, Mr. Ntsunyani. In our today's lesson, we are going to talk about preparation of salts. The BGCSE syllabus defines a salt as a chemical compound containing either an ammonium ion or a metal ion and a negative ion that is obtained from an acid. That is, a salt is a substance that contains either an ammonium ion, NH4+, or a metal ion, and let me use plus to represent and a negative ion that is obtained from an acid. As an example, we've got two salts here. We've got ammonium sulphate and magnesium nitrate. Ammonium sulphate has the ions NH4 and SO4 2-, and magnesium nitrate has the ions Mg2+ and the nitrate ion NO3-. The NH4 in ammonium sulphate is an ammonium ion, and the SO4 2- ion is obtained from sulfuric acid, and the magnesium ion in magnesium nitrate is a metal ion, and the nitrate ion is obtained from nitric acid. This is to bring this definition to life that says a salt contains either an ammonium ion or a metal ion and a negative ion which is obtained from an acid. Therefore, many salts are prepared using reactions of acids. You have so far learned about 3 reactions of acids, and those reactions are the metal plus acid reaction, the acid plus base reaction, and the acid plus carbonate reaction. Let's do a quick recap on these reactions. You have learned that metal plus acid reactions produces a salt and a gas. And when this gas is tested for by using a burning splint, you learned that there will be a pop sound that is produced. There is a pop sound, and that pop sound indicates that the gas is hydrogen. Therefore, we conclude that metals and acid react together to produce hydrogen gas. And acid and bases react together in a reaction that is called a neutralization reaction to produce salt and water is the only product. And acid and carbonates react together to produce a salt plus water plus a gas. And you learned that this gas that is produced in the reaction of carbonates, when it is tested for by using lime water, you learned that this gas will change the lime water to a milky color, to a white color. A white precipitate is formed, and we know the gas that behaves this way or that gives this result is carbon dioxide. Therefore, we conclude that acid and carbonates react together to produce the salt, water, and the gas carbon dioxide. Both of these three reactions produces salts. This is why these reactions are used to produce salt. We will now look at the procedure that we can use to produce a soluble salt by using any of these three reactions. As an example, we will look at the preparation of the salt copper 2 sulphate using an acid carbonate reaction, which we have just said. An acid will react with a carbonate, CO3 2- to produce a salt, carbon dioxide, and water. This is an ionic reaction or ionic equation for the reaction. I want to encourage you to do a little bit of practice on ionic equations. Let us look at the procedure. The first step is to warm up the acid that you are going to use. And what is the purpose of warming up this acid? Why can't we just use this acid as cold? The purpose of warming up our acid here is simply to increase the rate of the reaction, to make the reaction to be faster, to increase the rate of the reaction in correct chemistry terms, to make the reaction to be faster, to increase the rate of the reaction. This is why the acid has to be hot. All right, and then step number 2 is to add your carbonate, but you don't just pour the whole carbonate into the acid at once. You add it one spatula at a time until excess has been added. The word excess here means more than enough, more than is required, more than necessary, more than enough. Okay? What observation would we make as we add the copper 2 carbonate into the acid? We have said that acids react with carbonates to produce water as one of the products, a salt as the other product, and the gas carbon dioxide as the other product. Because of this carbon dioxide gas that is produced, we will therefore observe bubbles. Bubbles indicating the production of a gas, bubbles of carbon dioxide. Each time we add the carbonate into the acid, the carbonate will be used up. Therefore, we will also observe the carbonate decrease in size, carbonate decrease. You will decrease or disappear in the solution. Some books may say you will observe the carbonate dissolves in the solution. I don't like using this word. I'll just use it because it is there in your books, dissolves. The carbonate decreases in size, disappears in the solution, dissolves in the solution. We are using copper 2 carbonate here, and copper is a transition metal, and there is a property of transition metals that says these compounds form, or these metals, the transition metals, form colored compounds. They form colored compounds. Bear with my pen. My pen is not so well today. They form colored compounds. Because they form colored compounds and copper is a transition metal, we therefore expect this solution to be colored, and indeed it will be colored blue. So a blue solution will be formed. So one of the observations here is that there is a blue solution that is formed. Sulfuric acid is colorless. When we add copper 2 carbonate to it, a blue solution is formed. So there are 3 observations here. The first one is that the blue solution will be formed. The second one is that bubbles of carbon dioxide will be produced. The third one is that the carbonate decreases in size or disappears or dissolves in the solution. The next question says, what is the purpose of adding more than enough, more than is required of the carbonate? I want you to remember that sulfuric acid is a strong acid, and strong acids are corrosive. So the purpose of adding excess copper 2 carbonate is to ensure that all the corrosive acid is neutralized, so that we do not have traces of the acid in our salt. Otherwise, the salt will be corrosive. And how would we know that we have added excess carbonate? We would know that we have added excess carbonate when we observe that the reaction has come to an end, but we still have some carbonate in the solution. So when we begin to observe our carbonate settling down at the bottom of our beaker, but there are no more bubbles being observed here, that will signify that the reaction has come to an end, and all the carbonate that is settling down to the bottom is excess. So we will know that we have added excess when we observe no more bubbles, but with some carbonate in the container, with carbonate settled at the bottom of the beaker. If we do not have any carbonate here, then we can conclude that there is no reaction taking place, because there is no carbonate, there are no reactant, there is no other reactant to react with the acid. But if we have some carbonates at the bottom of the beaker, then we would say, yes, we have carbonate, but we don't have all the acid. We have used up all the acid. So we will know we've added excess when we have no more bubbles, but we still have some carbonate left. And then step number 3 says, filter off to remove the unreacted carbonate. So you filter the solution to remove the unreacted carbonate. Pour your mixture like that into a funnel fitted with a filter paper. The copper 2 sulphate solution will pass through and collect as filtrate, and the unreacted copper 2 carbonate will remain trapped in the filter paper as residue. So this will be our residue, and the residue is the unreacted or excess. Bear with my pen is not so well today. The unreacted or excess carbonate remains trapped in the filter paper as residue, and the salt solution, which is copper 2 sulphate, solution or aqueous copper 2 sulfate, it is important to write these two as capital letters, capital I, and enclose it in the brackets. Copper 2 sulfate passes through and collects as filtrate. And what observations would we make? The first observation is that the copper 2 carbonate, the excess carbonate, remains trapped in the filter paper as a residue. And the second observation is that a blue filtrate of copper 2 sulfate passes through the filter paper. Filtrate or copper 2 sulfate, let me just cancel that, copper 2 sulfate solution, aqueous copper 2 sulfate solution and aqueous state collects as filtrate. Oh, my pen is having all sorts of troubles today. Collect as filtrate, while the copper 2 carbonate remains trapped in their filter paper as residue. The next step says heat or boil the filtrate to evaporate excess water. After filtering, take the filtrate, transfer it into an evaporating dish, and then boil it, heat it in order to evaporate excess water. So excess water evaporates. So note that it says excess water. The statement doesn't say to evaporate all the water, but just excess water. So that means you will stop heating while you still have some solution left. This is very, very important. If you were to heat until all of this water evaporates and you remain with only the crystals, this solid will be decomposed by the heat and your crystals will lose the water of crystallization. They will dehydrate. They will lose water of crystallization. They will decompose under heat and dehydrate, lose the water that is part of the crystal lattice that holds the particles together to make a crystal lattice, and your crystals would tend to be whitish in color. We call this kind of copper 2 sulfate anhydrous copper 2 sulfate. Copper 2 sulfate that has been dehydrated. Copper 2 sulfate that has got no water of crystallization. Anhydrous copper 2 sulfate. We obtain anhydrous copper 2 sulfate if we heat to evaporate all the water. But we do not want to form an anhydrous product. We want to make a hydrated product, a product that has water. This is why we heat only to evaporate excess water, not all of the water. And then when we are satisfied that we have evaporated excess water, we will then cool the remaining mixture to allow for crystallization. This word crystallization simply means the formation of crystals out of solution. Crystallization is the opposite of dissolving. In dissolving, the solute disappears into the solution, and in crystallization, those crystals form out of solution. Formation of crystals out of solution, the opposite of dissolving. Crystals out of solution. Bear with my handwriting, it is very, very horrible today. but at least you can see. Okay, this is what you will get at the end. Nice crystals. If these crystals still contain a little bit of solution, dry them. And how do we dry our crystals? We dry them by rubbing between filter papers. By rubbing between, allow me to write BTWN for between filter papers. The filter papers will absorb the water out of the crystals and leave them dry. So let's take a very quick recap of what we discussed in the preparation of the salt. Number one, we add excess carbonate to a warm acid so that the reaction will be fast. And then we add excess carbonate so that we can dissolve all the corrosive acid. As we add the carbonate to the acid, we will observe bubbles indicating that there is a gas that is produced. We will observe a decrease in the mass of the carbonate because the carbonate is being used up, or it will disappear in the acid, or it will dissolve in the acid. If our carbonate is of a transition metal, then we will observe a colored solution being formed, a colored solution, and if it is copper, the solution will be blue. After adding excess carbonate to the acid, we filter to remove the unreacted carbonate. As we filter, the excess unreacted carbonate will be trapped in the filter paper as a residue while the salt solution passes as the filtrate. Then we take our filtrate and boil it in order to evaporate excess water. The reason why we only evaporate excess water is to prevent the loss of water of crystallization, which will result in the formation of an anhydrous product. Because we want to make a hydrated product, we only heat in order to evaporate excess water. Then we take the remaining mixture and cool it in order to allow for crystallization, which is the formation of crystals out of solution. And then finally, you dry your crystals by rubbing them between filter papers. Thank you very much for joining our today's lesson. If you have enjoyed our lesson, remember to subscribe to our channel. Remember, if you are also watching this lesson from YouTube, remember to subscribe to our online classroom at www.superiqsolutions.com www.superiqsolutions.com